So now we know how the different column works. If you want to analyze multiple columns at a time, how we can actually do it. But this time what we are going to do, we are going to discuss specifically about heat map and correlation. How we can find correlation between two columns. If one column increases, either the other one also increases or not. Or if it decreases, what is the amount on which it is decreasing. So to find the correlation between them, we are using something called as heat map or correlation. That is something we are going to do in this video. So let's jump into it and I'll see you on the other side. So we have discussed a lot about exploratory data analysis so far, like how to analyze the data, how to plot the distribution, how to analyze important information out of a particular data set. But now we are going to discuss about the correlation. Okay, let me tell you what is correlation. So for example, let's suppose I'm having a data set, okay, and in the data set I am having couple of factors, like I'm having the age of the person, okay, and apart from that I'm also having their birth year, okay, in which year he birth, and apart from that I'm having his salary in terms of LPA. Okay, let's suppose if a person is having age 24, okay, uh, let's suppose 23 years this time, so his birth year is 1998. Okay, so these are just the factors I am writing, and I am defining, okay, his salary is, let's suppose, 5 LPA. Okay, we are having some other person whose age is 25, so his birth year would be 1995 6. Okay, and his salary is, let's suppose, 7 LPA. Okay, again we are having 35 year of age, or 35 years is 1986, that is much higher, and let's suppose the salary is 25 LPA. Okay, so from this data set we can add multiple rows into this, but if I'm talking about analyzing each column at a time, which is age, birth year and salary, so from here you can see if the age increases, then birth year obviously decreases, right? If we are having a person whose age is, let's suppose, 3 years, we are having a kid whose age is 3 years, so his birth year would be 2019 or 18. Okay, salary obviously going to be 0. Okay, so the more age a person is having, the lesser birth year he will have. Okay, from here we can analyze it as well. Okay, and the more age a person is having, the better chances of a person having a better salary. Okay, so from here, if we are talking about the relation between age and salary, so they are having a positive relation. Age and salary is having a positive relation. Okay, why they are having a positive relation? Because if age of a person increases, his salary also increases. From age you can also treat it like an experience. If the experience of a person increases, salary also increases. Okay, but if I am comparing it by age and birth year, so if age increases, birth year decreases. Okay, a person having birth year 2000 is having age 21. A birth person having age to 1998 having age 23, right? So they are also related, but if age increases, salary increases. In this case, if age increases, birth year decreases. If birth year increases, age decreases. So they are also related, but negative correlation they are having. They are having positive correlation. Okay, in some of the cases there might be chances that it doesn't make any change. Okay, if age is something, like in some of the cases we are having, let's suppose, is location where the person is from. Okay, so age has nothing to do with the location. He might be from Delhi, he might be from let's suppose USA, right? From age is having no relation with the location. Okay, so this is called as the relation. How we can define the relation or correlation between multiple columns. And to define the correlation, we are having a math function that we are having. So let's suppose df is my main data frame. Okay, what I can do to define the correlation. Now the session is starting, it might be restarting, so it might take a couple of seconds. So what we can do to find the correlation between multiple columns, we are going to use something called as CORR. Okay, CORR will give you the correlation. Now named yes is not defined because first of all I need to run the code again. Once the data frame is there, I can execute it. So from here what we have got the correlation. Okay, and I have got the correlation between age, resting BP, cholesterol, fasting, uh, normal. So this is a string. Obviously we cannot find the correlation between a number and a string. We can find it with the max HR, old peak, disease. Okay, so from here you can see we are having couple of numbers. What are these numbers? So these numbers are, like, if I am telling you the basic correlation, so correlation between this age and this age column is obviously 1.0, means 100%. If the column, this age column is changing, so obviously it is 100% dependent on age column only. So that is why the diagonal columns are 1.0, means they are fully connected, because resting BP and resting BT obviously 100% correlation. Okay, if I'm comparing the relation between age and resting BP, we are having 0.25, means if age increases, resting BP also increases. Okay, but the problem is it is 0.25. Okay, the more closer to it to 1, the better correlation it is having. So from here you can see it is having 0.25, means 25% correlation. Okay, it is not exactly 25, but we can treat it like that. It is not, it is correlated but not that much. Okay, the value near to 0 will give you almost 0 correlation. Like here you can see 0.09, almost 0, no correlation. Okay, and if we are having negative correlation, for example here we are having minus 0.38. Minus 0.38 means if the age increases, it is between age and max HR. So if age increases, maximum heart rate decreases. This is the mean of negative correlation. Okay, closer to 0 means no correlation. Negative, closer to -1 means fully negative correlation, means if age increase, max HR decreases. If max HR decreases, age increases. That is a negative correlation. Minus 0.38, that is why we are having negative. Okay, and if age increases and resting BP increases, obviously positive correlation. Age decreases, this the resting BP also decreases, obviously that is also positive correlation. Okay, if one increase, other decrease, then it is a negative correlation. Okay, the value close to 0, no correlation. Okay, from here you can see we cannot find some of the columns which are having very positive or very negative correlation. Some of them are having correlation, like we are having 40% correlation, 0.40, minus 0.40 between heart disease and maximum heart rate, but it is not a strong correlation. Okay, from here we can find the correlation between multiple columns. In this data set there is no strong correlation we are having, but in some of the data set we can find a very strong correlation. And the benefit of finding correlation is, let's suppose if age increases, okay, heart disease, chances of heart disease increases. Okay, age decreases, chances of heart rate decreases, and we are having, let's suppose, 95% correlation between age and heart disease. So the obviously I will not take rest of the columns. I will only take, if I want to know, okay, if a particular person is having heart disease, obviously I will directly correlate with age. What is his age? If age is 90, obviously he might have it, because if age is having direct correlation with heart disease. Okay, here we are not having, we are just having 0.28% correlation, which is not that much. Okay, now it might be really difficult for you to analyze and going through each and every number. So what we can use, we can also use something called as a heat map. Okay, what we can do, we can use SNS dot heat map. Here I can define the whole data frame df dot correlation. This will make a heat map. Okay, maximum correlation is 0.10, which is the diagonal elements. Minimum correlation is minus 0.4, because we are not having -1 negative correlation. Okay, so from here what we can analyze, if we want to know about this particular correlation pointed, we are having no column having such correlation. If I want to know about negative 0.4 correlation, if I want to check, so we are having in max HR and heart disease, we are having correlation 0.4%, means a negative correlation they are having. If one increases, another decreases, but we are having a correlation. This one is something we can take, this one we can take this one and this one. These are the four columns, four correlation we can take between max HR age, max HR disease, disease max HR, and age max HR. Okay, these are the columns that I can definitely take. Okay, so this is the basic, I would say, correlation that we can find using heat maps. Okay, again we are also having some other matter, like we can use pair plot, that we are going to discuss in the next lecture. So yes, that's pretty much it, and I'll see you in the next one. So I'm hoping the concept is clear about the heat maps and correlation, how we can find the correlation, how we can plot a heat map, and how I can analyze the heat map as well to see if there is any correlation or not. If I still have any doubt, please let me know. Otherwise, I'll see you in the next one. Bye.